Again, I mean, all of this is stuff that you guys, I know I've seen before. So I apologize if it feels like I'm going through it too fast, but this is just some easy stuff. Acids and bases. Introducing acids and bases here. Acidic, alkaline, basic. It's measured in logarithmic scale, which I think I have in a little bit here. Neutral is pH of 7. Anything that direction, less than, it's going to be acidic. Anything that way to 14. Alkaline, basic. Okay. Every time you go down a number, so if we go from 7 to 6, again, that's a change in 10. Remember, it's logarithmic. So going from a pH of 7 to a pH of 6 is going to be 10 times more acidic at the pH of 6 than compared to 7. Okay. Am I going to ask you to calculate pH? No. I just want you to be aware of what it is. And you do. You had it hammered into you when you were doing chemistry class. Okay. Solution has more OH, hydroxide ions. It's going to be a base, which is alkaline. OHs love to be a proton acceptor, and that's what a base is. Acids are proton donors. They love to donate. And that is just referred to as acidic. Okay. I'm just kind of underlining some big concepts that I know you learned in the prereq for this class. And these are probably things that you should remember that you would probably see on a multiple choice type question on exam. Not a lot of massive short answer type questions so far, guys. We'll be talking a lot about buffers when it comes to helping to maintain in the blood system. We talk a lot about pH balance. We talk about pH in terms of helping to regulate gas exchange within the lungs, gas exchange within tissues. When it comes to buffers, we'll talk about this as well. When it comes to urine, acidic contents of the stomach. So we will see bicarbonate ion quite a bit. So just I have it underlined, guys, so you can really remember what that is, because we're going to be talking about bicarbonate ion a lot when it comes to pH balance, when it comes to holding on to CO2. It's going to be a major buffer system within the body. So understanding what bicarbonate ion is, HCO3 minus, what is it? It's a major buffer. Carbonic acid is what we call bicarbonate ion when you attach Mr. Hydrogen ion to it. Okay. And like I said, we're talking about this in blood, urine, respiratory system, a bunch of different things. So understanding and remembering what carbonic acid is and what bicarbonate ion is are some pretty important things. Again, is it a short answer question? No. Is it a multiple choice question or a matching question? Hell yeah. We have a nice little kind of homeostatic balance mechanism for pH. You can see it. Just, I'm not going to ask you that yet. I'll ask you that later. I'm not going to ask you that part now. What I want you to know are really what these two things are. Okay. Why are they important? Why are they important? because they are major buffers. Okay. One helps to buffer excess acid buildup. One helps to buffer excess base alkaline activity buildup. No. The unique thing about carbon, guys, is its ability to bind with 4 different things. Okay. 1, 2, 3, 4. It can bind with a lot of things. It can make extremely, extremely, extremely long chains of carbons, hydrocarbons. It can make a ring structure. And it's that complexity that allows it to make so many varied things. So in organic chemistry, right, carbon and hydrogen there, we are going to be able to do a lot of different things. Make proteins, make carbohydrates, make DNA, make proteins. Did I say that? I don't know. All of your biomolecules are based on this ability for carbon to do a number of fantastic things. Whether it's make a long chain of them, called hydrocarbons, okay, or make rings. And then we can add things to them and we can make them fantastical. I can have that fantastic little ring and I can add a few things here to the little doodads. I can add some things and I can add an R group, functional group to it. And I can make this thing into a hormone, tweak some of the parts and pieces of that R group, and I can make it from estrogen into testosterone, into vitamin D. I can do a whole bunch of fantastic things because of the chemistry of that carbon molecule. That's all they're trying to reiterate to you here. Here they're showing you a bunch of varied, fun, fantastic things. Am I going to ask you functional groups? Heck no. Okay. Are we going to see, carboxylic acids, ketones? We'll talk about ketones maybe a little bit when we get into cellular respiration metabolism. Okay. And alcohol always has an OH on it. Aldehydes. Am I going to ask you these functional groups and what are they called? No. Okay. We're going to be referencing some chemistry of how these things act. Yes. Am I going to use these kind of by name? A handful of them I will. Okay. But I don't want you to spend 500 hours memorizing something that I probably won't ask. So please just don't spend 500 hours trying to memorize these functional groups because I'm not going to ask.